My name is Bruno Baptista, and I'm here to present you Check Out This Mesh. And I'm a principal engineer and tech advisor at Talkdesk, a company that provides contact center software in the cloud. And I'm also an Eclipse Foundation committer and Coimbra Jerk co-organizer here in Portugal, and also part of the organization of the J Nation conference, also here in Portugal, where I am. So today we are going to talk about observability in general, and I'm gonna also talk to you about why we are using quarkus to create these services and how microservices and observability are important, and I'm gonna show you a demo with that. So to start with, so why quarkus? So quarkus is deemed as a supersonic subatomic Java, so a new framework to create microservices that will start very fast and that will take not as many resources as classical containers. So it can be used as imperative and reactive programming paradigms, and it's also developer friendly because it has a set of functional tools that you can use to build your applications, like live reloading of your code and live test reloading, and makes everything a lot easier. So it was created with microservices in mind, also to be used with native mode, in the sense that you can build your code to native mode with CrawlVM, which will lead you to create services with even smaller footprints, both in memory and disk space, targeting fast startup. And it has a full stack, so it has all the usual APIs that you are used to. So JAX-RS, all the microprofile libraries that you can use, Camel for integrations, and a bunch of other extensions that you can use with quarkus. So, and about microprofile, so it's based with CDI, has, as I mentioned, the JAX-RS and the JSON-B for JSON serialization, and you have also a lot of other features that come with microprofile, like config, health check. So if you are using your service in a Kubernetes environment, you will need to have the liveness and the readiness checks. So Kubernetes knows if your service is up and it's also ready to serve requests. Open tracing to distributed request tracing between services, and the JOT, the JSON Web Tokens standard that deals with authentication tokens with OAuth2 and JSON Web Tokens. Open API to document your REST endpoints, REST client for client requests from inside your service, and also fault tolerance functionalities. We can go through some of these APIs later in the demo that we are going to see. So other cool stuff. So we can package these quarkus applications in a very compact way. As I mentioned, live reloading while coding is available, and other cool stuff like integration with Flyway for automated database schema handling, and chorus filters, and many other extensions. So it has now 2 years, and I bet that you have seen some other great presentations about quarkus before this current presentation. So the stack has been around for several years. So the microprofile libraries and the CDI and JAX-RS are kind of part of Jakarta EE. And but the way all these APIs is glued together makes the difference, and that's why it can start very quickly and have a small footprint. So based on standards, we can use our familiar APIs with it, and it has a great community. So in relation with performance, so this was some tests that were done a while back about quarkus, JVM, and native mode. So on a particular environment. So we can see some curious things. So it starts already very fast, the JVM mode. But the native mode, it's orders of magnitude better at start time and also at memory time. But in requests per second, you can see that you have less throughput and also higher latency. This is because the JVM run, the version with the JVM takes advantage of the optimizations and the just-in-time optimizations, and the native mode is kind of locked to a particular profile of optimizations and cannot evolve with the execution of the runtime. And that's why you have less throughput with this, but you can have many more native services serving your requests. So it's a matter of balancing what you need. If you need a service that's always on, that will adapt, that has a higher throughput, or if you can go native, because some functionalities might not be available in native mode, because if you are using some kind of reflection inside your code, that can be a problem. So microservices. And what is a microservice? It's a really tiny service. And how tiny it needs to be. So this is kind of the obvious question when we talk about microservices, but microservices has a bit correlated with size, but it's not even the most important thing. So according to microservice IO, so a microservice has to be highly maintainable and testable, loosely coupled. So you have to have an independent domain for that service. So you have to find the best domain for that service, and that's the responsibility of a particular service. If you start to mix domains in a service, that will cause you problems. Or if, for example, you have one database and you have two microservices that use the same schema, that will create a coupling at the database schema level that will prevent independent evolution of both services. So that can be a problem, because you need to be able to deploy it independently. And if you are sharing some kind of resource between services, that makes it very, very hard or even impossible. And organized around service capability. So here, hence the domain. And it's owned by a small team. And here enters the size of the service, because it is really the amount of code that a small team can develop inside a repository. So usually this type of architecture is used by companies that do Scrum. And a Scrum team can go up to 9 people usually. And that gives you the amount, the size of your service. It's the amount of code that team can produce and can handle in a productive way. So also, when you talk about microservices, and if you search microservices on Google, and those are the kinds of images that you will get, you will find a lot of service. You will find yourself with a lot of service, because each particular domain will have its own. So you also need to take care of automated deployment. Your endpoints need to be very intelligent, and you need to automate everything at the build time, at the testing level, and also the deployment level. And also very important, decentralized and automated control. And you cannot control what you cannot see, hence observability. It's a hard name, at least for me, So observability, it's the classical definition that you can find in Wikipedia or something. It relates the concept to a measure of how well the internal state of a system can be inferred from knowledge of the external outputs. It's something that's intimately related with controllability. But one other definition that I like more is that for a software system, it's the capability to allow a human to ask and answer questions. And that makes all the difference. And we have 4 different vectors around observability. So logging, tracing, metrics, and alerting. So in relation to logging, when you have microservices, you need to have centralized logging. You cannot just log between machines and see the logs there. You need to aggregate the logs in some kind of stack that is usually used for that, like the Elk stack, so Elasticsearch, Logstash, and Kibana, and also use some other standard like OpenTelemetry. So you need to add context to every line that you log, so you can know what was happening at the time. So I don't know, user IDs, things that are not PII. That's important not to log, and the region, if you have a cloud that is multi-region, things that will allow you to get a bit more of context when you are debugging. Should also use JSON format, because if you output your logs with JSON, it will be very easy to create custom filters and search your logs for particular patterns. It will make your life a lot easier when you search for problems. Also, you need to set up the proper log levels that you want to see. So error if the execution was aborted, a warning if something went wrong, but the execution could continue, and information to validate the proper execution. Let me give you an example. So if you are running a Quartz job, you need to say, okay, job has started, I'm doing this step of the job, and then I have finished the job. So this will help you to understand if something that needs to happen actually happened. So everything else, debug, trace, and so on, should not be on your production logs, because if you log too much, it will harm you, because it will make everything harder to find, and it will also make everything slower to find, because you will have much more logging. Also, it's important to log between system boundaries, to make sure that things went out and were received later. But for that, much better is a distributed tracing. So when you have distributed tracing, you are able to follow a request from the beginning, since it's received on a REST endpoint. And if a particular service needs to ask for information to other services, you will be able to see the trace to the other service and how long it took, and all the different steps that were taken until you got the response. And that's very important to understand where an error happened, if it happens, and also to understand where are the bottlenecks, which requests are taking longer, and so on. So we'll pinpoint errors and performance bottlenecks very easily. Also very important, metrics. So you have quite a few APIs or specs around metrics. So you have microprofile metrics, micrometer that is widely used on Spring Boot and also Quarkus, and the new OpenTelemetry standard that also addresses metrics. And you have quite a few closed source application performance managers like New Relic that will show you metrics that are being collected, both at the JVM level, but also custom metrics that you can create. All these metrics will be the base for SLAs, service level agreements, and that will provide you if the requests are being served as required, what's the uptime of your services, error rates, things like that. And with all this knowledge, both from logs, traces, and metrics, you can create alarms. Because you have many services, and you cannot spend your life looking at all these raw data. You need to actually understand on your data, on your logs, and also on your metrics, what are exceptional conditions that you want to know and be alerted when they happen, so you can take some action or mitigate some problem. And then you have many applications that can generate those alerts. Most famously, probably Alert Manager from Grafana. There are also some tools like Bugsnag for particular problems that happen on your logs. And also the application performance managers usually provide this kind of functionality. Okay, so now we have a demo, and we will show you two services. So the legume service that will receive a REST call with a new legume, and we'll send that legume through RabbitMQ, and that the superhero service will transform the legume in a superhero, and we'll store it on a database. For database, we are using Postgres, and we will show everything later on Grafana. So let's go to the demo. Okay, so let me stop the presentation here, and let me show you the code. So here we have this is a standard Maven project. So we have the legume service and the hero service here. They are quite similar. Let me show you the first service that's more interesting in my opinion, because it sends the message. So everything starts on the resource, and here we apply a pattern. So we put all the annotations related with OpenAPI and JAX-RS. So these are the definition of this endpoint and the JAX-RS annotations for that particular endpoint as well on an interface. Because as you can see, there are a lot of annotations, and that will hide the actual logic that we want to implement. So then we implement that interface in a legume resource. Usually we will also have a repository layer, but here we are just injecting the entity manager and operating the database directly from the resource. And then we have a message sender to send messages to RabbitMQ. So to simplify things, we have a provision method here that is invoked through the init method. So we have a post to an init method that will call this provision endpoint. This is just to initiate a database. And what it will do is it will create two legumes, a carrot and a zucchini. And once they are added to the database here, so we create a legume, we will send the message to the other service. So you can see also here that we have other, so we also have the list, the standard list. When we do a get legumes, we will have the list of all the legumes in the database. And we are using fault tolerance annotations here. So we have, after a timeout of half a second, we will call the fallback here, which is this method that will just generate the failed legume to you. So other micro-profile things before I show you the dashboards. For example, the health check. So when Kubernetes starts a service, it will expect you to have, it will expect for the live endpoint on the liveness check to be up. So the service will start and that endpoint will be published. And once it does, we are going to return that the service is up. And the readiness is a bit more complex. So when we do a readiness check here, we are going to basically test the connection to the database. We are going to do a simple select one to Postgres to make sure that not only the connection is okay, but the database is live and it's replying to you. So that will ensure that everything is okay. And if it returns you a 1, it's up. Everything else, well, something went wrong and you say you are down. And if a connection exception happened, you will be down. So Kubernetes will not divert load to your service in that case. So let's see the demo. So right now I have here my localhost 3000 that has nothing. So all the infrastructure is on Docker Compose. And we will have a RabbitMQ, a database, Postgres, the vegetables, and the superhero methods. And on that regard, we'll have also here the observability Docker Compose that has all the stack related with the observability part. So starting from below. So FluentD is used to collect all the logs, and we store them on a Cassandra database here. Here, so we use the sidecar pattern to collect the Jaeger traces, so the open traces, and here you have the sidecar for the vegetables service, and then everything will get trained into Prometheus that will be then consumed by Grafana. So let me just stop here Slack because it's making too much noise, and let's take a request. So right now everything is stopped and I'm gonna start it here. So I have a command, an alias that I use here. So let me show you. So I have an alias observability that basically starts a Docker Compose with that Docker Compose that I show you, the observability, and also an observability network that basically sets up the ports for all these. And so right now everything should be down. Yeah. And I say up. And it will start everything for us. So here we have some useful endpoints. This is on the demo. I will show you the link later because this is accessible on GitHub. And let's see if the services are live. So yeah, this one, it is. The hero service, the superhero service should be live as well. So it's 200 OK with up. And also the readiness. So everything is up as well. And also the other one is also up. Okay, so let's check if we have something, any legumes on the database. So no, we have an empty. So we have an empty list of legumes. We are now, before I add anything, Grafana should be up. let me show you the logs. So let's see the vegetables and service. And here we have the logs being collected, and we have Loki to see them. And because we have everything in JSON format, we have all these metadata that we can search. Right now, we only want to see the messages. So I'm going to click here, and everything gets filtered apart from the message. So we can see here that the service started in less than 5 seconds. So let's go again here and do the initialization of the database. So in here, we have either the carrot and a zucchini, like I showed you in the code. And we should have 2 legumes there. So yes, so the carrots and the zucchini here. And if we go to heroes, yeah, you have a super carrot and we have a super zucchini. So the other service received the message, and everything seems to be working properly. And so we have logs for that. So you see here that I've sent so because this happens on the same second, messages in the same second are not really in order. So we have to get some sense of it. So this is why it's very important to have like the traces, because we can go here to vegetables, provision, and we can see exactly what happened. So let me increase this. So we call the provision endpoint. The execution took all this time. And then we sent a message. So we are actually tracking the traces using RabbitMQ. So we can track not just REST requests between service. We can also track all kinds of operations between service. We just need to instrument and pass the right information between message in the message. So this can create the right traces in the right context. So, and that's what we did here. So the RabbitMQ message provides also the context for the trace, and then we send the message and we received it here in the hero service, and we send the second message, and then we added here the other legume. So a few things are interesting in here. So you can see that the first time that we try to send a message is much slower than the second time. This is because we are starting and loading a bunch of classes, and the context needs some processing. But the next time everything is okay, and it will execute much faster. Same way here on the add hero, because the first time this is executed, it took this time, but the second message that we try, it will execute also much faster. So as you can see, not only you can check the flow of all the requests, but you can actually have some meaningful information about it. So I'm going to show you also very quickly, because we are almost out of time, the metrics. So we are using micrometer here, and if we invoke this endpoint, you will get all kinds of metrics here, and they are available on dashboards. So I have here a quarkus dashboard that you can download, and you can see all the default JVM messages, boards that are built from those requests. And you can see a fail here because I have so this is Portugal local time. I had this running this afternoon for a while, and then I disconnected and I started it again when I started this presentation. And that's it for now. So I don't know if you have any questions. Okay, we have one question. What? So question number one. what are some observability tools that will work across on-premise and cloud deployments? So, as I mentioned, the Elk Stash, you can actually have an Elk Stash on-premise and also on the cloud. Grafana also, so everything that I showed you here can run on-premise. So I run it from a Docker Compose. You just need to scale it to run on-premise. But there are many cloud companies that provide this type of functionality based on Grafana, and even Elasticsearch has similar offerings where you can use the same tools, but in a cloud environment. So second question, what are some of the best practice tips when alerts are triggered? So the best thing that you can do when you have an alert is that you have prepared before the alert happens. So for each alert, you need to have kind of a template. So you need to have somewhere written, okay, this is an alert. It's triggered by this condition. This is why it's a problem. And this is a list of actions that you should take as a cause of this alert. So it's not just, okay, let's create an alert because this is fun. No, you need to actually think of what you are going to do when you create the alert and have it documented. Otherwise, this will be picked by some support team, some SRE team, some DevOps team that will not have the context that you had when you created the alert. And if everything is normalized that way, they can take meaningful action before waking up someone. And yeah, because each alert has its own context, and you need to document that somewhere. So any other questions? Okay, that's all. Okay, thanks everyone. So let me show you only my last slide here. So if you want to download everything, you have the links there. So slides and code. And this presentation was implemented with the help of Andrei Ilikas. You can follow him there as well. And thanks very much for attending.